Hello and welcome. This training is titled Building Accessibility for the Disabled, and it is module NS9. My name is Amber Armstrong, and I will be the presenter for this training. A little bit about me. I started my career in the architectural field and worked as a project manager on small to medium-sized construction projects. After 7 years, I transitioned to a plans examiner and worked for 2 municipal jurisdictions with populations around 100,000 people each for a total of 18 years. During that time, I received certification as an accessibility inspector and plans examiner, a certified building official, and a certified fire marshal. I have served on code development committees in my state, various committees for ICC, and currently serve on the Building Code Action Committee and Accessibility Exam Development Committee. I am also a former commissioner for the Oklahoma Uniform Building Code Commission, and presently I am working as a building code consultant, specifically assisting architects and engineers solve code requirements when designing projects to meet the International Building Code. Today, we will learn and master the universal accessibility requirements in the Bangladesh National Building Code 2020 edition. This module will address accessibility in commercial and public buildings. At the completion of this module, you will be able to identify which occupancies require barrier-free accessibility, determine components of a building that are required to be accessible, and apply design and construction requirements to building components to accomplish accessibility. You will find the Universal Accessibility Technical Requirements in Volume 1, Part 3, Appendix D. The code defines accessibility as the provision in a plot or a building or a facility or any part thereof that can be approached, entered, and used without assistance by persons with temporary or permanent physical limitations. So let's think about this for a minute. There's two very important parts to this definition. First is that the facility is entered and used without assistance. Somebody who is disabled needs to be able to use the building the same manner that somebody who isn't disabled can. And the only way that they can do that is if they can do that on their own. The other part of the definition that we want to talk about is temporary or permanent physical limitations. So it doesn't matter if the person is permanently disabled or temporarily disabled, they're still going to need parts of the building designed so that they can use that building. The code defines persons with disability as persons whose mobility and capacity to use a building or part thereof or a facility are affected due to one or more physical and/or sensory disabilities or impairments. What types of disabilities are there? You have somebody in a wheelchair, and this may be what you think of first when you hear the word disability, but it's not the only disability that there is. This particular one does drive a lot of the requirements that we're going to talk about today, but it's not the only thing. You have ambulant disabled people, somebody who uses crutches, which this is an example of a temporary disability, or maybe somebody who uses a walker. They can walk on level ground. They can even walk up steps with a handrail. They just need a little extra maneuvering clearance. You also have somebody who's visually impaired. They may be totally blind or just have low vision. They can feel their way around a room, but may not detect a protruding object, such as a wall-mounted light. There are other disabilities that aren't quite as distinguishable as these, such as hearing impairment, or maybe somebody with a heart condition or a breathing problem. They can walk short distances, but they need areas to rest. You also have people who have limited use of their hands. They can't grip a surface or twist the wrist. So these are all the things that we're going to consider today when we talk about the requirements to design a building with handicap accessibility. So this training has 2 parts. First, we're going to talk about the provisions for accessibility by occupancy type. And once we know where to provide accessibility, then we're going to talk about the design and construction requirements, the technical requirements of how to provide that accessibility. So for residential buildings, you should provide accessible areas from the public footpath and parking areas to the lift lobby, the lift, from the lift lobby to all housing units and all communal facilities, excluding apartments without a lift. Should also provide at least one toilet per housing unit and at least one room in every 200 guest rooms that are accessible. For hostels and dormitories, all public areas intended for access by staff, students, or visitors, including access to public footpath and parking areas, should be accessible, and at least one room in every 100 rooms should be accessible. For schools, colleges, universities, or other educational buildings, all areas intended for access by staff, students, or public use, including access to public footpath and parking, should be accessible. In hospitals, clinics, homes for the aged, and institutions for the physically challenged, all areas intended for access by staff, patients, inmates, or public use shall be accessible. At office buildings, all areas intended for access by employees or public, including parking, shall be accessible, and you should provide at least one accessible toilet facility on each floor. For small shops and markets and kitchen markets, provide accessibility from parking and or public footpath to the sales service counter, and where the counter service is provided, at least one counter shall be accessible. For large shops and markets, all areas intended for access by employees or public, including access to public footpaths and parking, shall be accessible. You should provide seats for people who cannot stand or walk for long periods and free spaces for wheelchairs. Also, at least one accessible toilet per floor connected to an accessible route. And you should also provide seats and free space in all public foyers, or foyers in all public buildings. Factories, workshops, industrial buildings, and administration buildings and depots, all areas intended for access by employees and public use shall be accessible. And in parking garage, private garage, repair garage, and showrooms, the requirements are prescribed in accordance with sections D24 and D25, and those have to do with the parking requirements. In religious buildings and crematoria, all areas intended for access by people, including access to public footpath and parking, shall be accessible. In restaurants, food courts, fast food outlets, and other public eating outlets, all areas intended for access by employees or public, including access to public footpaths and parking, is accessible. And where fixed seats are provided, shall be at least one accessible wheelchair space per 10 seats. In cinemas, theaters, stadia, or other places of assembly with permanent seating, all areas intended for access by performers and areas prescribed by this code for spectators or public use, including access to the public footpath and parking, shall be accessible. And you should provide at least one wheelchair space with an adjacent companion seat for every 150 seats. In sports complexes, public gymnasiums, and public swimming pools, all areas intended for public access should be accessible. And you need to provide at least one accessible shower compartment and one water closet compartment for males and for females separately. In public transportation stations, airports, riverports, bus terminals, interchanges, and other passenger transport terminals, all areas intended for access by employees or public use, including areas prescribed in section D.3.2.7, shall be accessible. And the waiting areas should be provided with seats. Tactile warnings should guide passengers to footpath, ticket counters, waiting areas, and other services. And there should preferably be no level change between platform and deck of the transport. However, if it is unavoidable, provide that level change by lift or ramp. Now let's talk about design and construction requirements within the building. As I said, wheelchair use is what directs a lot of the requirements that we have in the code. There are a lot of dimensions that are shown on the screen that have importance. For instance, we mount signs at a certain height because somebody in a wheelchair has a lower eye level, as it's indicated, maybe up to 1,300 millimeters. Also, you have knee and toe clearance because of where the legs are positioned in a wheelchair and you need to roll underneath a counter surface or something like that. We need to make sure that you can clear that, and we know that based on the dimensions that are shown on the screen. Another very important dimension is the width of the wheelchair, being able to maneuver the wheelchair through a door or through a corridor or other paths of egress. As you can see, the width of the wheelchair may be indicated as 660 millimeters, but we also have to think about the wheelchair user operating the wheels and allowing for space for their hands. So the dimensions that we see on the screen are what are going to drive a lot of what we see in the code. Minimum space allowances for wheelchair users. Depending upon the nearest obstruction and the direction of movement, a wheelchair user shall be considered for two approaches and shall require a minimum 900 by 1200 millimeter unobstructed floor area. As you can see on the slide, that is either for a forward approach or for a parallel approach. As we saw on the slide before, those dimensions come from the footprint of the wheelchair. You would provide these space allowances at check-in or check-out lanes, sinks, or drinking fountains, or other locations where a wheelchair might sit. To facilitate both parallel and forward approaches for wheelchair users, a minimum clear floor space of 1200 by 1200 millimeters is provided as shown on the slide. Along the accessible route is a continuous and unobstructed path that starts from the entry and shall continue through all accessible elements and spaces within a plot and buildings or facilities thereof up to the exit termination. As you can see on the slide, there's several different dimensions that we need to pay attention to. Minimum clearance for any place is 900 millimeters. You might find that at a door opening, a check-in, check-out counter. If it's a straight portion of the building, say a corridor, a ramp, a stair, the minimum dimension is 1200 millimeters. And this is where you would typically have a single wheelchair passing with a walking person simultaneously. Along the path, you may find that you need places to turn around. If it's for a manually operated wheelchair, it's 1500 by 1500 millimeters. And for a power wheelchair, it's 2250 by 2250 millimeters. And you'll also notice that if you have an area that two wheelchairs need to pass by each other, the minimum dimension is 1800 millimeters. We'll talk about additional requirements on accessible routes and other components later in this presentation. For someone who is visually impaired, a protruding object from a wall or from a post becomes a very dangerous hazard. If they don't know that the object is there, they may hit their head and suffer a brain injury. So someone who has low vision or is totally blind typically uses a white cane to detect any hazards. On the right, you see that they will tap the cane back and forth in a sweeping motion. On the left, you see that as that cane is tapping back and forth, it projects beyond the edge of the body about 150 millimeters on either side. And you can tell at the angle that the cane is shown that if there was an object at a certain mounting height, they would be able to detect that. Along pedestrian routes, any obstacle, projection, or protrusion should be avoided. Overhead projections should be a minimum of 2000 millimeters above the floor. Wall-mounted objects projecting from the wall 100 millimeters or less is not likely to cause injury and is exempted from any requirements. If the object projects more than 100 millimeters, the bottom edge of the projection should be not more than 580 millimeters above the floor. If it's a projection that does not extend that close to the floor, then you would want to place a barrier under that projection that is no more than 580 millimeters above the floor. As you can see, the person who is using their cane would come in contact with any projection that is within that 580 millimeters dimension. Any protruding object shall not reduce the clear width required for an accessible route. Just like with wall-mounted objects, post-mounted objects are also a hazard. The most common object projecting from a post would be a sign. If you have an overhead sign, then the bottom edge should be no closer than 2,000 millimeters to the floor. If the sign or other object is below that mark, then the lowest edge should be no more than 580 millimeters above the floor, and the object should project no more than 300 millimeters from the post. So let's put it all together with protruding objects and accessories inside of a building. As you can see here, we have a wall-mounted sign which has the bottom edge located at 2,000 millimeters above the finished floor. We have a wall-mounted light that does not project more than 100 millimeters from the wall face, so no additional protection is needed. The fire extinguisher cabinet is shown at a maximum 100 millimeters from the finished face of the wall. However, if that did project more than 100 millimeters, the bottom of the cabinet would need to be located at 580 millimeters or lower, or you would need to provide some sort of protection underneath that cabinet. Drinking fountains, as shown here, can be recessed into an alcove, and provided that the front of the drinking fountain does not project more than 100 millimeters from the alcove, no additional protection is needed. So here we see two different sets of drinking fountains and how they can become protruding objects. On the left, there's no protection around the drinking fountain, and somebody who is following the face of this wall would easily run into that drinking fountain and could injure themselves. On the right, you can see that the lower drinking fountain, the underneath side of that, is mounted at 580 millimeters above the pavement, so nothing additional is needed. But on the left, they've added a bracket with the lower edge at 580 millimeters, and this protects this drinking fountain from being a protruding object. Now let's look at a post-mounted object. Here we have a sign indicating the location of a handicap parking place. The post and the sign are also located in the sidewalk, which is part of the pedestrian way. If the sign projects more than 100 millimeters from the post, then the lowest edge would need to be not more than 580 millimeters above the floor. Let's look at two more examples of protruding objects. On the left, you have a service counter at the bar. As you can see, that counter is located in the circulation path and projects more than 100 millimeters away from the bar. On the right, you have a handrail extension that projects out into the pedestrian way on the sidewalk. But in this location, it appears that the return is not more than 580 millimeters above the pavement, so this actually is projected and is not a protruding object. What did you learn? What is the maximum distance an object can project from a post? 100 millimeters? 200 millimeters? 300 millimeters? 400 millimeters? And the answer is 300 millimeters. Surface quality of floor space for pavement and interior floor surface. All pavement or floor surfaces required to be accessible shall be firm, even, slip resistant, and stable. Notice I didn't say smooth. This isn't required. As you can see on the slide on the right, this is a pavement out of brick pavers, and as long as the gap between the pavers is not more than 12 millimeters, this is completely compliant. So what about this footpath? Do you think it's accessible? Let's check. It is constructed of gravel, but could gravel be accessible? And the answer to that is yes. It is accessible provided that the slope is compliant, which we'll talk about in later slides. The gravel has been compacted and is not loose, so this fits the criteria of firm, even, slip-resistant, and stable. Any change of level in an accessible route shall have a maximum slope of 1 in 12 in the direction of travel. For the visually impaired, we should provide special marking either at the top and bottom of the slope or for the full slope. This is to draw attention for someone who is visually impaired or if there is low lighting. Change in level. Any change in level in an accessible route shall generally have a gradient of at least 1 unit vertical to 12 units horizontal towards the direction of travel. Where the change of vertical level is up to 150 millimeters, a steeper slope is allowed. So from 0 to 75 millimeters of vertical change and up to 600 millimeters in length, a slope can be increased to 1 unit vertical in 8 units horizontal. For more than 75 millimeters and up to 150 millimeters in vertical change of elevation and a maximum allowable length of 1500 millimeters, you can use a slope of 1 unit vertical to 10 units horizontal. And again, where more than 150 millimeters of vertical change occurs and a maximum length of 9,000 millimeters, the maximum slope is 1 unit vertical to 12 units horizontal. Since some ambulant disabled persons can maneuver steps and find that more convenient and safer, accessibility provisions for both ramps and steps should be given. In addition to these slopes, we will discuss additional requirements for the ramps and steps at a later time. Another thing to consider on the floor finish is a grating. Gratings are shown here in the slide. We have two different types. We have a circular grate and a linear grate. You want to make sure that the gaps in these gratings are not greater than 12 millimeters in any direction, and that they are flat and at the same elevation as the slope is the pavement around them. And in the case of a linear opening, such as on the right-hand side, that opening is aligned perpendicular to the direction of travel. So what's the hazard here? If the opening is too large, the wheel of a wheelchair could get stuck and cause it to tip over, which would cause injury to a person. Or maybe if you're using a cane, the cane could get stuck and the person could fall. And here we show where a wheelchair has gotten stuck in the grating. This is a good example of why the opening should not be more than 12 millimeters in any direction. Now what about the slide on the right? You have grating that's used as a tread on a stair. Is this appropriate? Provided that the openings are no more than 12 millimeters in any direction, it is appropriate for a tread. Surface texture. So in an accessible route, apart from the requirements we just discussed, floor surfaces with tactile indicators shall be required. In such cases, a dot-type surface texture on the floor shall indicate a warning, while a line-type surface texture on the floor shall indicate the intended path of travel. For a visually impaired person, there are multiple types of hazards along an accessible route. Some are part of construction and some are not. An example would be of vehicular traffic, or as we just talked about, a change in level. For these potential hazards, we need clues for the user, and we'll talk about this in greater length later in this presentation. What did you learn? Which of the following characteristics are not required for pavement on an accessible route? Even, firm, slip resistant, smooth. And the answer is smooth. Public access way. The minimum unobstructed width for an accessible public access way, such as a footpath, a corridor, a foot overbridge, or an underpass, should be 1,200 millimeters. All such ways shall have a 1,500 by 1,500 millimeter space every 30 meters in length to facilitate the crossing or the turning of users, which you've seen on the screen. And no encroachment into the required width by an obstruction or protruding object is allowed. Now, if the pathway width is at least 1,500 millimeters, there is no additional requirements for turning spaces required. Vehicular approach to a building. To facilitate persons with a disability approaching by vehicles, the driveway, walkway, and accessible parking surfaces within the site shall either be merged to a common level or connected by a ramp. So for flats, apartments, hotels, lodging, mess, boarding house, dormitory, healthcare, custodial institution for adults, educational facilities beyond secondary level preschool facilities, offices and essential services, small shops, refueling stations, and large shops, and large and small assembly with fixed seats, large and small assembly without fixed seats, and sports facilities, at least one accessible route from a vehicle parking to accessible entrances shall be provided. Here is an example of a public access way where everything is on the same level. As you can see, the parking space on the right is at the same level as the footpath that crosses and that is connected to at the same level to the path that connects to the building. Once you get to the building, the entrance needs to be accessible. So at least one accessible entrance door connects to an accessible route for the following occupancy groups. And you need to provide directional sign posted at non-accessible entrances and parking areas. Remember that the accessible route is 1,200 millimeters wide. The entrance door will comply with section D.8, which we'll talk about in a bit. So here is an accessible entrance to a building. You can see that the symbol of accessibility is located on the glass. It could be a lot larger so that you can see it from a further distance. And that would be for somebody who couldn't read the sign that says accessible entrance. What did you learn? What is the minimum headroom clearance at an accessible route? 1,800 millimeters, 2,000 millimeters, 2,200 millimeters, 2,400 millimeters. And the answer is 2,000 millimeters. Accessible routes, corridors, and paths. So just like a public access way, which is further away from the building, as you get closer to the building, you need to provide additional features for the accessible route. Again, it should be not more than 30 meters in length at a stretch. And every 30 meters, you would want to provide seating for somebody who can't walk great distances. Like I mentioned earlier, somebody with a heart condition or somebody with a breathing condition. The route should be a minimum 1,200 millimeters wide. However, if there's one-way travel on this route, you can reduce down to 900 millimeters. And be sure to provide headroom clearance of 2,000 millimeters. So here's an example of an accessible route. Let's see if it complies. Benches are provided every 300 meters. The width of the paving is at least 1,200 millimeters wide and has not been reduced below 900 millimeters at the bench. But what about the overhead clearance? It appears that the tree branches are less than 2 meters above the path, so this would not comply. Along the accessible route, surface finishes should be free of sharp edges. So on the left, we have a picture of objects projecting from the building. Because the lower edge is below 580 millimeters, this isn't a protruding object, but it does have sharp edges. On the right, we have sandstone wall that also has rough surfaces and sharp edges. As I have mentioned, the accessible route shall be free of any obstruction or protrusion. If you do have any obstacle along the route, shall maintain the minimum width of 900 millimeters. So here we have a couple of examples of those obstacles. On the left, you have an oval, let's say it's a column, and you can see that the width is still 900 millimeters at that obstruction. On the right, you have two columns, one on either side of the path, and we still have maintained the 900 millimeter width. Any obstacle shall have a color that contrasts with its background. So we talked about protruding objects as being an overhead hazard, but what if the quote protruding object or the hazard is a part of the building itself? So let's take the picture on the screen, which is an open stair where there's opening underneath. As the stair run comes down to the main level, the headroom clearance will decrease and decrease. And at the point that that headroom clearance is at 2,000 millimeters above the finished floor, you need to protect against that hazard. And again, just like with a protruding object, you want to place some sort of a barrier that is at least 500 or no more than 580 millimeters above the floor. So here are two examples of an overhead hazard that's created by a stair construction and two different ways of treating the protection. So on the left, you can see that a curb has been constructed, which would alert somebody to the hazard above. There's also furniture located around this area, which would keep somebody from walking into this hazard. But since furniture is movable, you do need to provide something that's permanent, such as the curb. On the right, a bench was provided. So it provides seating for somebody, it's functional, as well as stopping somebody from walking into this hazard above. Here are two more examples of an overhead hazard that's created by building construction. So on the left, you have buttresses that project away from the building that project over the path, and the way that they have protected this is with a curb below each one of the buttresses. On the right, you'll see that there is cross bracing located between the columns. And as that cross bracing comes all the way down to the floor, you know that there's going to be a portion of that that is under 2,000 millimeters. Now, while this is not directly in the path of travel, someone who is walking down this corridor that may list off to one side could easily run into this and injure themselves. Accessible doors. An accessible doorway will ensure access to the building to all people without any assistance. So, general requirements at all doors, the threshold should be at the same level, but it can be up to a maximum 20 millimeters above the surface as long as it's sloped. The accessible door at a bathroom and toilet doors should swing outwards to facilitate external emergency assistance. Doors should contrast with adjacent walls so that they are not obstructed or hidden. Accessible door width. A single leaf of an accessible doorway shall provide 900 millimeters minimum clear opening between the face of the door leaf when it's open 90 degrees and the face of the opposite jamb. This would be the same for a sliding door, except you would provide that from the face of the jamb to the face of the door. If you have a double leaf door, only one of the operable leaves must meet this requirement. This is often misunderstood, and many people think that the door leaf needs to be 900 millimeters, and that provides the clear opening. But as you can see from this graphic and the one that I'm going to show you in just a minute, the thickness of the door, the thickness of the jamb reduces the opening if the door leaf was 900 millimeters. So that's why you want to make sure that you provide the 900 millimeters in the clear opening. So here's a little better graphic to illustrate how the wheelchair maneuvers through the door and why that clear opening needs to be from the face of the door to the face of the jamb. As you can see here, the thickness of the door reduces the opening size, the thickness of the jamb reduces the opening size. So if you had provided the door leaf at 900 millimeters, you're going to end up with something that's less the thickness of the door and the thickness of the jamb. So one of the most difficult tasks to perform when you're in a wheelchair is to go through a door. And that's why we provide extra clearances at the doors, which are illustrated on this slide. So there are two sides of a door. There's a pull side and a push side. And as you can see, they're labeled on the slide, but just think about it. If the door is coming towards you, you're pulling it towards you, it's the pull side. If you're pushing the door away from you, it's the push side. Now, on the pull side of a door, you want to provide clear floor space of 1500 by 1500 millimeters, and that needs to be positioned with at least 600 millimeters beyond the edge of the door. On the push side, the clearance is 1200 millimeters by 1200 millimeters with only 300 millimeters beyond the edge of the door. For a two-way swinging door, both sides shall have clearance based on a pull side, and you should provide a vision pane, which we will go over in a minute. Now, on the next slide, I'm going to show you a little bit more about why you need to provide these clearances, but I do want to point out, and it's easy to see on this slide, that as you're pulling the door away from you, that extra clearance would be for your foot plate, and as you're pushing the door towards you, that extra clearance beyond the edge of the door would be so that you could just slightly twist to be able to open the door handle. Let's look at why maneuvering clearances are so important at a door. Here you see someone in a wheelchair that has approached the door from the pull side. As the person has reached out for the door handle, they have maneuvered their wheelchair slightly to the left. Once they begin pulling the door towards them, they will need to rotate the wheelchair even further to the left, and as you can see, the foot plates have extended well beyond the edge of the door frame. Once the door is open 90 degrees, they can turn themselves back and align with the door opening, and as you can see from the other side, they will be able to make it through the door without any problems. Now, what about if this person was approaching from the push side of the door? They would approach the same way as they did in picture 1. However, when pushing the door away from you, they will not need to maneuver as far past the door jamb as was shown here. Accessible door hardware. If not automatic, all accessories that are required for operating an accessible door, such as the door handles, fasteners, locks, shall be manually operable by one hand with ease. The height of the accessory shall be within the range of 900 millimeters to 1100 millimeters from the finished floor, and door handles are recommended over doorknobs. As you see on the screen, you have a U-shaped lever or a grab bar handle. So here we see how somebody who does not have full use over their hand are able to open the door with the hardware provided. If somebody doesn't have the gripping strength to be able to grab the grab bar loop, they can push their hand through and use their wrist. Maybe they don't have the ability to twist their wrist, so they're using a closed fist to push down on the lever. On the right, you see that they are not able to use their fingers to pull on the door handle, so they're using their palm. Vision panel. So just a couple of slides ago, we talked about where vision panels would be required. So for the safety of the ambulant disabled or wheelchair users, all two-way swinging doors across the accessible route shall have a transparent vision panel. The vision panel should be a minimum 150 millimeters wide, and it should be located to the bottom edge a maximum 800 millimeters above the floor, to the top edge a minimum 1500 millimeters above the floor, and it should always be located on the opposite side of the hinge. Turnstile. Whenever a turnstile is placed on an accessible route, an accessible gate with a clear width of at least 900 millimeters shall be provided beside the turnstile. You would also locate a gate or a door alongside a revolving door. And note that this is not a one-for-one gate to turnstile. You may locate a gate or a door at each grouping of turnstile or revolving door. And here is an example where you have an accessible gate that's located adjacent to 3 turnstiles. Now the gate, remember, needs to be a minimum 90 millimeters wide when the gate is open. You see that the symbol of accessibility is shown on the gate. And think about why this is required. A wheelchair would not be able to go through the turnstile, just by the way the turnstile functions. You also are going to have maybe a mother with a baby stroller or an older person with a cane. They would also have difficulty going through the turnstile. What did you learn? The minimum clear floor space required on the push side of a door is 680 by 1080 millimeters, 900 by 1200 millimeters, 1200 by 1200 millimeters, 1500 by 1500 millimeters. And the answer is 1200 millimeters by 1200 millimeters. True or false? The minimum accessible door leaf width is 900 millimeters. And the answer is false. Handrails and grab bars. Handrails and grab bars are very important for anybody and for somebody who has a disability. Things to consider are that they provide an accurate size and shape, they're slip resistant, free of sharp or abrasive edges or corners, the rail or the bar is secure to the supporting wall or floor, it's a continuous gripping surface, maintains constant height, it has a contrast to its surrounding, and it doesn't encroach in minimum clearances. All grab bars or handrails in a facility should have a circular section of 35 to 50 millimeters external diameter or an equivalent gripping surface. Clearance between the rail and the adjacent wall should be between 40 and 60 millimeters, but the maximum projection should be 90 millimeters. And if you'll notice, you add those numbers up, that doesn't, you can't have the max on both. If the rail is located in a recess, there should be a minimum 450 millimeter clearance above the rail. The height of a handrail is 850 to 950 millimeters above the floor or the stair nosing. Grab bars vary based on its location. We'll talk about that in a little bit. And both handrails and grab bars should resist a vertical or horizontally applied force of 1.3 kN. Curb ramps should be kept in the pedestrian route, in other words, in the sidewalk. They should not protrude out into the vehicular way. If such a protrusion is unavoidable, the curb ramp should be constructed with flared sides, and the slope of those sides should be 1 in 10. For a level change under 150 millimeters, it does not require handrails. Now, if you look at this picture, they've painted the flared sides. And while that looks like it would be a good idea to draw attention to that, the paint is actually a slippery surface and would not be allowed. If you remember, if the curb ramp is less than 150 millimeters rise, the slope can be steeper than 1 in 12. Anything over 150 millimeters is a 1 in 12. Those gradients were listed in Table 3.D.2. If the level change is over 150 millimeters or the length is more than 1,500 millimeters, then you should comply with the section D.11 for ramps. The ramp should have a width not less than 900 millimeters. The surface of the ramp and the flared sides should be slip resistant. There should be detectable warning of contrasting color and texture, complying with section D.29 at the base of the ramp. The size should be minimum 600 millimeters in the direction of travel times the width of the ramp, and located a maximum 300 millimeters from the lowest edge of the slope. The flared sides can slope not greater than 1 in 10. If locating the curb ramp in the vehicular way is unavoidable, this is how you would construct it. The curb ramp is still 900 millimeters wide. You have flared sides on either side with the slope of 1 in 10. And what this picture doesn't show is the detectable warning at the base of the ramp. You would still need to provide that. Here we have an example of a well-constructed curb ramp. You have parking spaces on either side of an access aisle, and the curb ramp is located in the sidewalk, so it's not projecting out into the vehicular way. Detectable warning is provided at the landing to warn somebody about walking out into the vehicular way. The slope of the ramp appears to be 1 in 12, and the curb ramp is located close to the main entrance. So what about this curb ramp? Do you think it complies? Let's take a look. Here you have a painted curb ramp, which you would think would be a good thing because this curb ramp is projecting out into the vehicular way. However, as we said before, the painting on the curb ramp makes it slippery. Also, it appears that there's plenty of room within the sidewalk that the curb ramp could have been constructed there, so this would not be an acceptable allowance to let the curb ramp out into the vehicular way. So what about this curb ramp? Do you think it complies? We have access aisles on either side of the handicap parking place, so the curb ramp is not actually in the access aisle. It also does not project out into the vehicular way. It appears that the slope is close to a 1 in 12. However, you can see that the detectable warning is missing from the base of the curb ramp. Something that maybe is not quite as noticeable is because the access aisle is on the other side of the parking place. When somebody exits their vehicle, they would have to go out into the vehicular way to get access to the curb ramp. So for those reasons, this curb ramp would not comply. So where should we put curb ramps? They should be located within the footpath walkway, not within the vehicular path and not within the parking area. As you can see from this slide, the curb ramps direct the pedestrian crossing perpendicular to the footpath. For visually impaired, curb ramp should line up with the pedestrian crossing. So here's an example. You'll note that the curb ramps line up from side to side. There is a tactile warning before you get out into the drive approach. If you have a divided street that the divider is raised, you'll need to provide a transition there as well. As you can see on the slide, you provide the curb ramp, and at the top you have a landing of 1,200 millimeters in the direction of travel by 1,500 millimeters wide, which allows for change of direction. And then you have the same thing adjacent to that so that you can transition to the next road. What did you learn? True or false? Detectable warnings are required at the top landing of curb ramps. And the answer is false. Accessible ramps. Accessible ramps shall be used to provide connectivity between levels having height difference of more than 150 millimeters within a facility which is not served by an accessible lift. So if you remember, we talked about the slope of a ramp, and that should follow table 3.d.2, but in no case should the ramp exceed a slope of 1 in 12. Ramps should have a minimum width of 1,200 millimeters. They should have a slip-resistant surface, and where the horizontal run exceeds 9 meters in length, should provide intermediate landings a minimum of 1,500 millimeters long. At that intermediate landing, provide tactile warning, which is a minimum length of 600 millimeters by the width of the ramp. Should also provide handrails on both sides of the ramp. Now, as you can see in this picture, the handrails are provided inside the width of the ramp. You cannot encroach within that 1,200 millimeters with the handrails, so in this case, the handrails should be 1,200 millimeters apart. Also, you should provide edge protection below the handrail. So here is an example of a long, straight ramp. You'll notice that there are handrails on both sides of the ramp and that the edge protection is provided in line with the handrails. You can also see that the handrail extension at the bottom of the ramp does project horizontally 30 or 300 millimeters. However, the return is higher than 580 millimeters above the sidewalk, and this would become a protruding object. There's also an intermediate landing provided because the ramp is longer than 9 meters in a length. Now, I also want to draw your attention to the way that this driveway has been crossed. Instead of a curb ramp on either side of the drive aisle, they've actually raised the drive aisle up to the level of the sidewalk. Now, they still put the detectable warning because even if it's at a same level, you are walking out in vehicular traffic. So here we have an example of a ramp that changes direction. Many of the requirements are the same as that for a straight run ramp. The width is still required to be 1,200 millimeters minimum. Handrails are required on both sides of the ramp as well as edge protection. The surface of the ramp needs to be slip resistant. And will provide intermediate landings where a ramp run exceeds 9 meters in length. However, at the change of direction, the landing shall be 1,500 by 1,500 millimeters square. Also should provide tactile warning at that landing that is 600 millimeters by 600 millimeters, which gives warning that there is a change of direction. So here's another example where we have actually two types of ramps. We have a ramp that changes direction, which is a U shape and not an L shape, but we also have a curb ramp. So we have features that are common and features that are different. You'll see that there is a landing at the bottom of the curb ramp, at the top of the curb ramp, which is also the landing at the regular ramp. You have an intermediate landing where the direction changes, and then you have a landing at the top of the ramp. Now on the ramp, for not the curb ramp, but the actual ramp portion, there are handrails that are provided on both sides, and they also have edge protection. The dimension of the landing that's at the top of the curb ramp and the top or the bottom of the ramp doesn't appear to be correct, because if the curb ramp is 900 millimeters wide, then and there's a change in direction from the curb ramp to the regular ramp, that landing should be a 1,500 by 1,500 millimeters square. So I mentioned that handrails are required on each side of the ramp. The height above the ramp to the top of the handrail should be 850 to 950 millimeters. You need to provide extension beyond the ramp surface, a minimum 300 millimeters horizontal. And the handrail extension shall return to the floor or to an adjacent wall. So here's another example of a ramp, and why I wanted to show this picture is that while we do have handrails on either side of the ramp, the handrail extensions are provided and the handrail extensions do proceed to the ground. At the base of the handrails, we don't have edge protection. Let's take a look at this ramp. What's missing? First off, there's no handrails. If there's no handrails, there's also no edge protection. And it's hard to tell from this picture, but it looks like the slope is greater than a 1 in 12. So all around, I would say this is not a good example of a ramp. On the previous slides, I've shown edge protection that is a part of the handrail, and I wanted to show this as a different example of providing a curb on the side of the ramp to provide edge protection. What did you learn? What is the maximum slope ratio for a 100 millimeter change in elevation? 1 vertical to 8 horizontal, 1 vertical to 10 horizontal, 1 vertical to 12 horizontal, or 1 vertical to 20 horizontal. And the answer is 1 vertical to 10 horizontal. Stairs do not provide accessibility for all persons with a disability. Stairs are an option for an ambulant disabled person, so we have requirements for accessible stairs. For safety reasons, stairs should not have open risers as shown on the left, or risers that have projected nosings as shown on the right. In both cases, these are tripping hazards. Let's talk about the steps in a stair. Continuous flights of steps shall have uniform tread dimensions, should be a maximum 150 millimeters riser height and a minimum 300 millimeters tread depth. Should provide detectable warnings at each stair nosing, and that warning should be 50 to 65 millimeters by the width of the tread. The nosing can project a maximum of 15 millimeters over the tread below, and a flight of steps should have not more than 16 steps. In addition to the detectable warnings on the nosings, we also need to provide detectable warnings at each of the landings. So at the main floor landing, provide a minimum 600 millimeters by the width of the stair, and locate that 300 millimeters or 1 tread depth from the tread, and a minimum 300 millimeters for leading edge of the door when open. Also provide detectable warnings at the intermediate landings, and that should be 300 millimeters by the width of the stair, and located a maximum 300 millimeters, again the width of the tread, from the tread. Handrails at stairs should be provided on both sides. The height should be 850 to 950 millimeters from the tread, nosing, or landing to the top of the handrail. There should be horizontal extensions, a minimum 300 millimeters long. Handrails should be continuous throughout the entire length of the stair, and the extensions should return to the floor or to an adjacent wall. Let's look at handrails at an exterior stair. We have handrails provided on each side of the stair, and actually in this particular case we have one down the middle. The height above the step and the landing is between 850 and 950 millimeters. As you can see on the right, we have horizontal extensions at the top and at the bottom. But take a look at the handrails on the stairs on the left. It might not be as easy to see, but the handrails are not continuous from one run to the next. So let's take a look at this picture and see what you think. We have a set of stairs on the right that have handrails on either side, so that's good. However, the handrails do not extend beyond the first riser, which could be a problem. This could cause a person to fall as they do not have anything to hold on to and may lose their balance at the landing. We have intermediate landings where we have a change of direction. However, if you look, there are only 900 millimeters in one direction, and they should be a minimum of 1500 by 1500 millimeters. Now we do have a landing at the bottom of the ramp and at the top of the ramp that are at least 1500 millimeters in the direction of travel, so that's a good thing. At each of the ramps, we should have handrails, and we have none. Now you may notice that the slope, that the rise of each section of the ramp is 150 millimeters, which wouldn't require handrails, but the total rise of the ramp is 450 millimeters, so you would need to provide handrails at each one of those locations. It does appear that we have edge protection at the ramp, so that's good. However, look at the slope. Again, since the total rise of the ramp is more than 450 millimeters, we would need to have a slope of 1 in 12. So as you can tell from this picture, there are some things that are right and some things that are not. What did you learn? Detectable warning at stair nosing edge shall be 35 to 50 millimeters, 40 to 55 millimeters, 45 to 60 millimeters, or 50 to 65 millimeters. And the answer is 50 to 65 millimeters. Accessible seating space and counter service. For workstations, dining tables, service counters, you should provide a clear floor space of 900 by 1200 millimeters, and that could be either for a side approach or for a forward approach. At the forward approach, you want to provide knee clearance under the table for a minimum depth of 480 millimeters and at least 700 millimeters above the finished floor. The surface of the writing surface or the service counter should be a maximum 800 millimeters above finished floor. So let's look at some examples. The first example is a workstation, has forward approach and knee clearances provided. Next, you have a counter, and the handicap portion does not have adequate knee clearance for wheelchair, so this would have a parallel approach. The service counter also does not have enough room for knee clearance, so this has a parallel approach. And at this eating counter, we have adequate knee clearance. However, condiments have been located on the counter and cannot be used by someone in a wheelchair. What did you learn? What is the maximum surface height above the floor for a workstation? 600 millimeters, 700 millimeters, 800 millimeters, 900 millimeters. And the answer is 800 millimeters. Sanitary provisions. There's quite a bit to cover in the sanitary provisions. And remember at the beginning of the slide, we talked about accessibility requirements by occupancy group. You should provide at least one accessible toilet per floor, or 5% of the total toilets in the building, whichever is larger. Prefer accessible toilets be unisex, but if not, at least one is required to be unisex. The minimum dimension of a compartment is 1500 by 1750 millimeters. And if a part of a group of toilets, say a compartment inside a room, should provide a minimum 1,200 millimeter wide path for the approach. We'll start with the fixtures within the washroom and the requirements for each one. So for an accessible wash basin, provide a minimum clear floor space that is 750 millimeters from the outside edge of the fixture to the adjacent wall by 1,200 millimeters deep. The fixture should be positioned a minimum 460 millimeters from the center of the fixture to the adjacent wall. The rim should be a maximum 850 millimeters above the finished floor and project a minimum 480 millimeters from the back wall. Provide knee and toe clearance underneath, which is a minimum 680 millimeters clear under the fixture for a distance of 200 millimeters from the face of the fixture, and the toe clearance is at a point starting 200 millimeters back. Provide a minimum 230 millimeters above the floor by 230 millimeters deep. Here's an example of a wash basin that's actually built into the construction and not an individual fixture. You still can provide the knee clearance and the toe clearance. It can still be mounted at the appropriate height. You can still provide clear floor space around the fixture, and be sure to provide the insulation at the pipes to keep from burning someone's legs. I have two more examples of different types of wash basins. These would have the same requirements as we discussed prior. Also note that the faucets and other controls of such basins shall not involve powerful grasping or twisting of the wrist, and shall preferably be automatic or lever operated. If you notice on the right, that has a sensor, so that's an automatic faucet, and the one on the left has a valve that you just push down. Accessible water closets have quite a few requirements. First off, the fixture should be positioned 460 to 480 millimeters from center of fixture to adjacent wall. The fixture sheet should be located 450 to 400 millimeters above finished floor, and the flush valve is either automatic or lever and should be located on the open side of the fixture, a minimum 600 millimeters by a maximum 1,050 millimeters above finished floor. Also provide a seat lid that folds up, a tank, or a backrest to support a person leaning backward. The fixture should project a minimum 750 millimeters from the back wall to allow for side transfer. And you need to provide 3 grab bars at the fixture. Remember, the grab bars are 40 by 50 millimeters diameter and are provided on 2 sides of the fixture. On the side wall, it's a minimum 600 millimeter long horizontal grab bar that's mounted 725 to 750 millimeters above finished floor to the top, and positioned a maximum 300 millimeters from the rear wall. Also, there is a 600 millimeter long vertical grab bar mounted 725 to 750 millimeters above the finished floor and positioned 900 millimeters from the rear wall to the center line of the bar. And if you'll notice, that vertical grab bar is right there at the same height as the horizontal grab bar, and it's preferable to provide that as a single L-shaped bar instead of 2 bars. Also, you need a fold-up grab bar on the open side, and that grab bar is a minimum 750 millimeters long at the horizontal portion. It's mounted at the same height, 725 to 750 millimeters to the top, and it's positioned 380 to 400 millimeters from the center line of the fixture and should extend a maximum 100 millimeters beyond the front of the rim of the water closet. This shows how a person would transfer from a wheelchair over to a water closet. It'll give you a good idea of why we have some of the clearance requirements that we just discussed in the last slide. So in picture number 1, the person is taking the transfer position, which is adjacent to the water closet. They would remove the armrest and set the brakes. In picture number 2, they would begin the transfer. At this point, they might use the grab bars that are located along the side of the water closet. And in picture number 3, they've now made the complete transfer and they are on the water closet. So this example is probably the closest example that I can come to as what's in the code. You see that the fold-up grab bar is provided, and it appears to be the appropriate distance from the center line of the fixture. The side grab bar is provided, and it seems to be the appropriate length. There is one thing missing. There is no vertical grab bar at this water closet. But notice all of the pieces and parts that are around that. And while they're not permanent and they are movable, they still will provide an obstruction for somebody in a wheelchair that needs that space. It'll make it more difficult for them to access this fixture. This is an example of a single-user toilet room. As you can see, the vertical grab bar is provided. There is a horizontal grab bar adjacent to the water closet. However, this one is a little longer than what's required in the code. There is a grab bar along the back of the water closet, which is not required in this code, but it is a good idea. I would not locate the paper towel dispenser in that location because it would interfere with someone pulling up alongside of the water closet to make the transfer that we just looked at. And this is missing the fold-up grab bar. I wanted to talk about the vertical grab bar and why that is a requirement in the code. Somebody who is using this fixture may not have the leg strength to lift them off of the water closet. So they have the vertical grab bar positioned so that they can actually pull themselves up. Now let's talk about accessible urinals. Where urinals are provided, at least one is wall hung and has a minimum 750 by 1200 millimeter clear floor space centered on the fixture. The fixture rim is mounted a maximum 400 millimeters above finished floor. You need to provide vertical grab bars on either side of the fixture. Those grab bars are a minimum of 600 millimeters long, and they're located 375 millimeters from the center line of fixture to the edge of the grab bar. They should also be mounted 1200 millimeters above finished floor to the center of the bar. Any privacy shields provided at the urinal should be located a minimum 120 millimeters from the grab bar. This is an example of an accessible urinal. All the components are provided. You have vertical grab bars on either side of the fixture. The fixture is the appropriate distance off of the floor. And you also have the privacy screen and the sidewall that are located properly away from the vertical grab bar. Also have to be concerned about the accessories that are in the washroom. So if you have a mirror, it's mounted 1000 millimeters above finished floor maximum. The flush control again is 600 to 1050 millimeters above finished floor. The emergency call button is 600 to 650 millimeters above finished floor. And other accessories such as the towel dispenser, the towel rail, the waste bin should all be between 1000 and 1200 millimeters above finished floor. You also need to provide signage outside of the washroom entrance. And that signage should comply with section D.26.2 and D.27, which we'll talk about in a minute. But as you can see on this sign, you provide the symbol of accessibility. There is a raised pictogram and letters. There should be braille underneath the letters, and we'll talk about the requirements for all of that later. What did you learn? How far from the rear wall at a water closet shall a vertical grab bar be located? 600 millimeters, 700 millimeters, 800 millimeters, 900 millimeters. And the answer is 900 millimeters. What is the minimum dimension from the center line of a wash basin to an adjacent wall? 460 millimeters, 480 millimeters, 500 millimeters, 520 millimeters. And the answer is 460 millimeters. So the doors to the accessible washroom and water closet compartments are similar to requirements that we've already talked about. But here's a few things to consider. The door to the washroom or compartment, when open 90 degrees, should provide the 900 millimeters clear opening. You need to provide maneuvering clearance outside of the door, and it's preferable that the door swing in the outward direction. And here is on the left another picture of the signage outside of the washroom door. So we've talked about grab bars in several different places, but let's talk about them one more time. The grab bars are 40 to 50 millimeters in diameter. Remember that the grab bar is positioned depending upon its function. So at water closets, they're 725 to 750 millimeters above the floor to the top of the bar. At a bathtub, they're 180 to 280 millimeters above the tub rim. And at a shower, they're 700 to 800 millimeters above the finished floor to the top. Vertical grab bars are at least 600 millimeters in length. They're mounted with the level with the horizontal grab bar in the water closet in the shower or bathtub, and at 1200 millimeters center of bar to the floor at urinals. What did you learn? What is the maximum diameter of a grab bar? 35 millimeters, 40 millimeters, 50 millimeters, 60 millimeters. And the answer is 50 millimeters. And I mentioned a minute ago about an emergency call button. They are required in all accessible toilets, water closet compartments, and washrooms. They need to be waterproof. They can either be push button or pull cord, and if you'll notice in this picture, there's actually both. It's located between 650 millimeters above finished floor, and be sure to place the bell outside the room where it is immediate attendance is available. So here's another layout for a multiple user bathroom, and you can see how when you fit all of the different requirements together, a possible layout for the plan. A couple things to note: we have the maneuvering clearance at the door, we have the clear space at the wash basin, we have the maneuvering clearance outside the compartment door, we have the 1200 millimeter minimum accessible route approach to the door, and then once you get in the compartment, we have all the different components that we've talked about. Bathing facilities. Let's talk about bathtubs. All residential occupancies are required to have accessible toilets per section D.3.2, and they also have to have accessible bathing facilities. It can be by a bathtub or a shower, and all the requirements are found in section D.20. Also, at sports facilities or public swimming pools, provide a shower compartment, one for male and one for female. So for bathtubs, you need to provide a clear floor space of 750 to 1200 millimeters along the length. Provide a minimum 450 millimeters clear to any other fixture, edge to edge. The tub should be a minimum 1500 millimeters in length, and the tub rim should be between 180 and 280 millimeters above finished floor. Be sure that the tub surface is slip resistant. You need to provide a seat at the tub. Can either be along the long edge or along the back, and it's a minimum 250 millimeters deep. The controls for the water should be a lever faucet, should be located a maximum 450 millimeters above the tub rim, Should also provide a handheld shower head with a flexible cord. And we've talked about grab bars. You need to provide a horizontal 900 millimeter long grab bar that's 180 to 280 millimeters above the tub rim, and a vertical grab bar 600 millimeters that's located at the outer edge of the tub with the lowest edge even with the horizontal grab bar. Showers. So here we have a diagram of a shower compartment. The internal dimension should be a minimum of 1500 by 1500 millimeters clear floor with a 900 by 1400 millimeters clear space outside of the shower for a side approach. Need to provide a bath seat, a minimum 400 by 750 millimeters and a maximum 450 millimeters above the floor. Provide lever controls, a maximum 580 millimeters from the corner, and that's adjacent to where the seat is. The shower head should be on a flexible cord that's also movable with a maximum height of 1200 millimeters above the finished floor. You'll notice that there are grab bars that are along the back edge of the seat and along the control wall. They're mounted 700 to 800 millimeters to the top above the floor. The one along the control wall is a minimum 900 millimeters long, and the one along the seat wall is 750 millimeters long. And again, the vertical grab bar is 600 millimeters long, and it's a maximum of 450 millimeters from the edge of the seat. And that's to make sure that if somebody is using the seat and they grab for the bar, that they don't have to reach too far and that they fall over. So if there's any level changes in the room, there's a maximum of 10 millimeters, and there should be a slope transition of 1 unit horizontal to 2 units. 1 unit vertical to 2 units horizontal. What did you learn? What is the minimum size of a water closet compartment? 900 by 1200 millimeters? 1200 by 1200 millimeters? 1500 by 1500 millimeters? 1500 by 1750 millimeters? And the answer is 1500 by 1750 millimeters. What is the minimum clear floor space required alongside of a bathtub? 750 by 1200 millimeters, 900 by 1200 millimeters, 1200 by 1200 millimeters, 1500 by 1500 millimeters. And the answer is 750 by 1200 millimeters. Kitchen facilities and residential occupancies should be accessible, and here is how you do that. There's one of two layouts. You can either go with the open layout on the left or the closed layout on the right. The open is like a pass-through, provide a clear aisle of 1015 millimeters. The closed layout is, or a U-shaped layout, need to provide 1,525 millimeters between cabinets, and that's due to turning a wheelchair. For appliances, you need to be clearly approachable from either the front or the parallel. When you have a front approach, the clear floor of 900 by 1200 millimeters needs to be provided. And remember, knee space underneath the counter will go back for a depth of 480 millimeters and should be a minimum 700 millimeters high. Knee space provided under cooking equipment should be insulated to protect against burns or abrasions. Need to make sure that 50% of the cabinet or storage is accessible, and that the working top, the sink, and the range are all within guidelines. On the left, you can see how the clear floor space is positioned at both the sink and the stovetop. At the sink, it's a forward approach, so there's knee and toe clearance provided underneath the counter. For the stove, the clear floor space is a parallel approach. On the right, it's just the opposite. You see that the base cabinets open up and provide knee clearance underneath the stove, and at the sink there would be a side approach or parallel approach provided. What did you learn? True or false? All of the cabinet storage in a kitchen must be accessible. And the answer is false. Lifts. If a lift is required in a building, at least one shall be accessible and shall have service at the entrance level. Should provide a lift lobby on the outside of the car, a minimum 1500 by 1500 millimeters square. The lift car shall be a minimum 1500 by 1725 millimeters, and the floor finish is smooth and slip resistant. Should provide horizontal grab bars along each side wall and the rear wall of the lift cab. The grab bars shall be mounted 850 to 950 millimeters above floor to the top of the bar. And on the sidewall, the grab bar shall be within 150 millimeters of the front of the car. The lift car door shall be a minimum of 900 millimeters clear, and the lift control panel should be located on the outside adjacent to the opening and on the inside of the lift car, a minimum 900 millimeters and a maximum 1200 millimeters above finished floor. There should be tactile markings and braille on the buttons. What did you learn? What is the maximum height above the lift car floor a control panel shall be located? 900 millimeters, 1200 millimeters, 1500 millimeters, 1800 millimeters. And the answer is 1200 millimeters. Eating outlets. Eating outlets with or without fixed seats shall have accessible seating areas. Where fixed seats are provided, the number of seats and the locations of those seats shall comply with section D.3.2, which we talked about at the beginning of this presentation. There should be a circulation aisle around all of the seating, a minimum 1200 millimeters wide. And where fixed seating is provided, there should be a minimum clear between seats of 750 millimeters measured along the outside edge of the table. The table surface shall be a maximum of 800 millimeters above finished floor, and there should be knee clearance provided underneath the surface, which is a minimum of 680 millimeters above the floor for a depth of a minimum 480 millimeters. So here is an example of an eating outlet. As you can see, there are some fixed seats available, but mostly the seats are not fixed. There should be access aisles around all of the seating, and the counter surfaces shall be of an appropriate height, as we just discussed. Remember, at the beginning of this, we talked about requirement for accessible parking areas based on the occupancy group, and that's detailed in section D.3, with the minimum number of parking stalls required coming from table 3.D.3. Need to locate the parking lot as near as possible to the accessible entrance and have an accessible route to the building, avoiding collision with backing vehicles. Now, if you look at the table, it'll tell you, based on the number of required parking spaces, how many accessible stalls you need. So for the first 50 stalls, you need one accessible parking space. For the next 400 stalls, you have that one plus one stall for every 100 parking spaces. And then anything above 450 stalls need to provide 6 parking spaces, accessible parking spaces. Let's look at a site plan for a parking lot. Are these accessible spaces in the correct location? There are parking spaces that are closer to the building, so that's one reason why these might not be in the right location. Next, Let's look at the access from the parking spaces to the building. As you can see, there's an access aisle that goes behind the parked cars, which could allow for a collision with a backing vehicle. And lastly, the crosswalk that goes towards the building crosses the drive aisle. So that could cause a collision with a car and someone in a wheelchair. Accessible parking stalls should be a minimum 3,200 millimeters wide by a minimum 4,800 millimeters deep. Access aisles should be 1,500 millimeters wide by the same depth, 4,800 millimeters. Should also provide a symbol of accessibility on the surface of the parking space, and that should be a white on blue background of either 1,000 by 1,000 millimeters or 15 to 1,500 millimeters. Parking space should be firm, non-slippery, leveled, solid surface, and you should have a sign posted at the entrance of the parking lot and at the parking space, and directional signage every change in direction. The size and location of the posted signs should ensure clear visibility along the accessible route. What did you learn? Which of the following dimensions is acceptable for the symbol of accessibility at an accessible parking space? 600 by 900 millimeters, 900 by 900 millimeters, 900 by 1,000 millimeters, 1,000 by 1,000 millimeters. And the answer is 1,000 by 1,000 millimeters. The symbol of accessibility. The symbol of accessibility is an internationally accepted language that shall be permanently and clearly displayed to indicate and or direct to the location of various accessible facilities in and around the building. The symbol, as you can see, is a person in a wheelchair that contrasts with the background. It's generally a white symbol on a blue background. Accessible buildings shall have symbols posted at the front road, inside premises, accessible parking, accessible routes, and the entry to the building. Also, you need to think about directional signage anywhere there's a change in direction in a main lobby, in a passageway, in a lift, entrance, toilet, car parks, anywhere. The directional signage with destination indicated is shown on the right, and where the location is not obvious or distant from a current viewpoint is where you want to put them. Let's look at examples of directional signage. On the left, you'll see that the accessible route indicates where the accessible ramp is located in relationship to the non-accessible ramp. On the right, you see a non-accessible door, which indicates the direction of the accessible door. This is not an appropriate location, as the signage should have been located earlier in the approach. In this location, it is too hard to see. Also need to provide accessible signs for the different services that are available. So as you see on the screen, we have a men's room, a women's room, or a telephone booth. Make sure that the sign includes the symbol of the service, such as the lift, telephone booth, toilet, staircase. And when you have a pictogram of a male and a female, make sure that it's tactile so that somebody can distinguish the difference between them. What did you learn? All symbols of accessibility shall face to the right or left. And the answer is right. Not only do we need to talk about what's on the sign, but we need to talk about how big the sign is. And the signage is based on the viewing distance. So as you can see in table 3.d.4, a viewing distance of 7 to 18 meters, the symbol size should be 100 by 100 millimeters. If it's above 18 meters to the sign, then the symbol size is anywhere from 200 by 200 to 450 by 450 millimeters. The letters are also important, and those are determined based on the viewing distance, and those are shown in table 3.d.5. So let's pick a couple here. Say if you're 2.5 meters from the sign, then the minimum height of the letter should be 100 millimeters. If you're 6 meters from the sign, the minimum height of the letter should be 200 millimeters. The location of the sign should clearly and legibly be identifiable from accessible route. You want to provide them at the change in direction in the accessible route, and they should be mounted to the center line of the sign 1,500 millimeters above finished floor. Tactile characters or symbols, when used on a sign, shall have a size between 16 to 50 millimeters and shall be raised at least 0.8 millimeters above the background surface. All signs shall be mounted at a height at least 1,500 millimeters above the floor level. If you recall back to the beginning when I showed the picture of the wheelchair and I said that the eye level is on average up to 1,300 millimeters, this would put the sign slightly above that so that it would be easily seen. Braille and pictographs. When Braille and tactile language is used, the Braille dot shall be raised in dome shape from the base and the sign shall be easy to touch and read. The height of the sign shall be a minimum 1,500 millimeters above the floor level. Pictographs, when used, shall be supported by an equivalent textual description placed directly below it. And here we have an example. So as you see on the sign, we have the pictogram, we have the symbol of accessibility, we have the identifier of what the service is, and then below that we have the tactile of the where it says women, and below that, which you cannot see from this slide, is the Braille lettering. What did you learn? Tactile characters or symbols shall be raised how many millimeters? 0.6, 0.8, 1.0, 1.2. And the answer is 0.8 millimeters. Grading of slip resistance. For the purpose of accessibility, surface materials to be used as floor finishes should be graded for slip resistance in both dry and wet conditions. A very good grading would receive a coefficient of friction of more than 0.75, and an example of that would be clay tiles, carpets, or dry rubber. A good grading would have a coefficient of surface friction between 0.75 to more than 0.4, and this would be concrete pavers, dry terrazzo, dry marble, and granite. A poor to fair grading would be between 0.4 and 0.2, and this would be wet and polished terrazzo tiles, marble, and granite. And a very poor grading would be less than 0.2 coefficient of friction, and that would be wet rubber. Tactile ground surface indicators. People with visual impairment find their way independently with the use of physical or sensory cues, such as landmarks or mind maps. For such users, we need to develop a logical, predictable, accessible route, designed free from barriers, hazards, or obstructions. Some physical cues include buildings, walls, ground surface, railing, fence, curbs, and so forth. The visually impaired person will use a white cane, underfoot, or echolocation to find their way. Cues should be inside and outside of the building. So what physical cues do you see in these pictures? On the left slide, a wall along a sidewalk on the right, There's a painted rolled curb along the drive, and to a certain degree, the large orbs along the drive provide physical cues. On the right slide, the wall along the right side of the drinking fountains protects the approach from the right, which is also a physical cue. Here are two physical cues that are built into the surroundings to alert the user to a potential hazard. On the left, you see a guardrail that has been placed underneath the stair to keep someone from walking into the underside of the stair. Unfortunately, it appears that this guardrail is higher than 580 millimeters above the finished floor. On the right, you see that a curb has been located at the edge of the walking surface to alert someone that there is potential hazard on the other side. For directional indicators, they should be a linear type, as shown on the left. They should be raised 5 millimeters, and they should be anywhere from 25 to 35 millimeters in length and have a sloped edge. Warning indicators should be a circular or dot type, also raised 5 millimeters, and the diameter should be between 25 and 35 millimeters, as shown on the right. So now let's put these all together. Here we see an accessible route that's located between 3 buildings, and there is a change in direction. At the end of the accessible route, you cross a footpath and then go into the roadway. So along the pathway that runs from the left to the right, there is a directional indicator that is 300 millimeters wide. You'll see that that comes up to the intersection of the 2 different accessible routes where the directional indicator is shown. From there, you can turn and go between the 2 buildings that are above the pathway, and you'll see that there's a directional indicator there, or you can continue on to the right until you get to the footpath. At the footpath, there's a change of condition here. You have cross traffic. It's foot traffic, but there is cross traffic. So the directional indicator is now 600 millimeters wide as opposed to 300 millimeters wide. And then when you get to the edge of the footpath, it's changed to a warning indicator that's 600 by 600 millimeters to warn you before you walk out into the roadway. What did you learn? The tactile ground indicator that provides physical cue for change in direction shall measure 300 by 300 millimeters, 300 by 600 millimeters, 600 by 600 millimeters, 600 by 900 millimeters. And the answer is 600 by 600 millimeters. This concludes module NS9. Thank you.